So in this video, I'm going to talk a little bit about some of the common errors that people make when finding limits, especially one-sided limits. So if we have a problem like this, you're given this function that's a piecewise defined function, and you're asked to find the two-side limit by examining the one-side limits first. Then we're going to start with the one-side limits and then check what those are, and then see if we get agreement to determine if we have a two-side limit, if that exists. So I'm going to start by saying that the limit as x goes to 0 from the left of f of x equals, that's where I'm starting from. I'm saying what's the left side limit. Um, and then since x is going to 0 from the left, then on a number line, x would be less than 0. So I'm going to use the top formula in the piecewise defined function. So then I'll have the limit as x goes to 0 from the left of cosine of x. Okay? And if I want, I could even make a note like below this, like down here or something, say like x is less than 0 if I wanted to. But this is pretty clear. I'm switching. I'm telling you I'm starting with f of x, and I switch over to cosine of x. And then that equals cosine of 0. I'm substituting because cosine is a continuous function. And then that equals, say, 1, right? For this one, I go from the right. Well, before we do that, what some people were doing is, which this part's okay, is they were leaving this part out and starting with that's fine. That's tolerable. What some were doing was leaving all of this out and just saying like this, which is really not clear. They weren't mentioning the limit at all. So if the question is about limits, you need to talk about limits. And then some people were leaving all of this out, and they were saying the limit from the left and then writing 1 without connecting why. How do you get 1 from that? So you need to do at least some of this intermediate stuff. You need to talk about limits, and you need to show me the connection between f and cosine. So if we were going to do x going to 0 from the right, then I would start like this, say what I'm doing, right? And then say, okay, well, this will be the limit as x goes to 0 from the right, and this will be of sine x plus 1. And I'm using parentheses to group these together because I'm finding the limit of the entire group. And now, since sine is continuous, I can plug in sine of 0 plus 1, which will be 0 plus 1, which is 1, right? And then ideally what I'll do is I'll say, these two guys agree, right? I'm saying, oh, they agree, the two one-side limits, therefore I have a two-side limit, so this equals 1. So also what some people will do is they will not mention that there's agreement. What I suspect they're doing is they calculate this, and in their head they go, those are the same. That means I have this. But then they won't write that down. You need to say that there's an agreement. That's why I know there's a two-side limit. And you could just like circle these guys and say agree. That's pretty good. You could write a sentence. You could say, since the two one-side limits are the same, that's the value of the two-side limit. That would be pretty good as well. You can use a sentence when you're talking about limits. You should be using limit notation wherever possible. And if you don't understand, what notation should I be using, ask for help. So next example, if I have something like this, and there's lots of ways for this to go sideways, where you're not quite doing things right. Either you're not using the notation quite right, or you're not showing the algebra quite right. So I'm going to start with there's a couple of errors that I commonly see. So the first one is this. So someone will go equals 0 squared plus 0 over 0, and it's a good idea. It's a good idea when you're finding a limit of a rational function, just go ahead and plug in the number and see what happens. Because sometimes you'll just get you get a result like 5 or 10 or something like that, and you're done. You got a number. Here I get 0 over 0. And what some people will do is they'll say, that equals 0, right? Well, that's actually quite wrong. 0 over 0 is an indeterminate form. It's not a single value. What this means is you don't really have anything. You don't have a result. So when you get this, that means that it was never valid to plug in to begin with. It was never going to work. Of course, you don't know that till you try it. But when you get 0 over 0, you should go back and cross out this equals. It was never okay. And some people will do that. They'll go back and cross this out, which is great. Some people will forget to or don't bother to. Okay, that's fine. But that means you're not done, right? Now you have to try some algebra or something else. So with this one, what some people will do is the following, or some variation. They'll say, okay, x squared plus x over x, arrow, and then they'll factor x times x plus 1 over x arrow and cancel x plus 1 arrow 1, something like that, right? And they don't mention limits at all. But if the problem is about limits, they need to mention the limit at least some of the time, at least part of the time. Um, this arrow here, what I'll usually comment is, well, what does that mean? What is this arrow doing? And usually they'll say, oh, well, I went from step 1 to step 2. I go, well, what does went to mean? They go, oh, well, I factored. Okay, did you change the function or is it the same? They say, well, I just factored, so it's the same thing. So I shouldn't do that. I should say that these are equal. If all I did was factor, these are equal. And then here, all I did was cancel, right? So this arrow is vague. It's non-specific. What is happening? So I should say that these are equal. This last arrow, I'll say, okay, what happened? Well, I put in 0 for x. Why? And they'll go, oh, well, way up here, it says x goes to 0. Like, well, way up here, come on. It needs to be down here. You need to tell me what you're doing. So it's totally fine that you're thinking this. As you're writing this out, you're thinking, oh, x goes to 0. So, I'll plug in 0 and get 1. But you have to say what's happening. So one of the problems with this is it's not mentioning the limit at all, right? And it's not really even implied. I mean, I guess you could argue here it's sort of implied, but that's don't leave it to your reader to figure out what you're doing. Or if this is like for a test or something, don't leave it to the grader to figure out what you're doing, because if they can't, they give you 0 credit because they don't know what you're doing. So don't leave that to chance. I'm going to show I'm going to show one or two appropriate ways to do this in a second, but I want to show another way that's inappropriate. So someone else might do this, and when I grade these, one person will make this mistake, or one person will make that mistake. Some people will do it all fine, but there's several different kinds of errors, and usually one person won't make all of them. So you might not make this kind of error. But here's another one. So how about this? Let's say we had like a x squared plus x over x equals x plus 1. I'm sorry, that's what I meant. Equals x times x plus 1 equals x plus 1 equals 1, something like that, which is kind of similar, but different. So there's no arrows here. There are no arrows here. But what's happening is this person is looking at the numerator and going, I have to factor. Cool, I factored. But I was dividing by x. So let me get rid of it. Now I have x plus 1 left over. And then they're going, okay, now I can plug in 0, right? Or they might even, maybe they'll even do this, in fact. They'll do this. They'll write, okay, equals limit. Oops. Limit as x goes to 0 of x plus 1 equals 1, right? So they're reminding you about the limit. So that's good, right? Many times someone will have one kind of error but not another, and they'll do certain things right and certain things wrong. So here, certainly, there should be a limit mentioned the entire time, right? But notice how they're taking this, they're factoring, and they're remembering, oh, that's right, I'm dividing by x, let me get rid of it, and so the x goes away. And if you think about these as being self-contained, then from here to here, you think, well, where did that x in the denominator go? And if you go from here to here, where did that x outside the parentheses go? And where did the parentheses go, right? So it's just not clear. So really, this should have the x the whole time. And it goes away in the next one. This should have parentheses. This one should have the limit the whole time. Oops. And this one should have the limit at the beginning. I can, use neater handwriting. Oops. Okay, I've somehow, yeah. Okay. Lovely time to hit the wrong button. So something like that. So this is actually really good because it's showing all of the components of the problem. And you might feel like, I don't want to write limit every time. Well, it's not that hard. Just write limit every time. And if you have to, space things out a little bit and go back at the end and make sure to put limit where it's supposed to be. Another thing you can do is you could say, starting from the beginning, you could say, okay, limit as x goes to 0 of x squared plus x over x. And then below that, you could say, okay, I'm going to do my algebra separately. So x squared plus x over x, this equals x times x plus 1 over x. So this equals x plus 1. And then come back up here and say, okay, well, this equals limit as x goes to 0 of x plus 1. And that equals 1. This would also be fine, which to me, this is just as much writing. I don't see this as being any better, but you're doing your algebra separately from the limit. if you want to do that, especially if the algebra is several steps, if the problem is more complicated, that's okay. You can do all your algebra. Don't refer to limits. Do all the algebra, and then go back. I'm sorry. So let me start over. Do all the algebra, and then go back and do just the limit, showing the starting point of your algebra with the ending point of your algebra. And you don't have to write limit every time. Just in the equation that includes reference to the limit, everything except for the result needs to have limit, basically. And there are exceptions to this. So, when in doubt, ask for help, ask a tutor, ask the instructor. I have one more here, and this is another, and it's not merely a notation error, it's a conceptual error. So if I were asking for, let's say, the limit to find, is this what I want? I might have a mistake here. No, let's find. So find the limit as x goes to 2 from the left of f of x over g of x, right? So we can tell, oh, well, the limit of f is going to be 3. The limit of g is going to be 5. So this is 3/5. But I really ought to say that that's what I'm doing. If I just write 3/5, I was thinking, well, find the limit of f and find the limit of g. But I never said I was doing that. So it's much better is to say, okay, limit as x goes to -2, or rather, sorry, 2 from the left of f of x over the limit as x goes to 2 from the right, oops, sorry, left, of g of x. So now this is 3/5, okay? That's totally clear. I'm showing the use of the quotient rule. If I leave this out, I'm not really showing much because the question will say this, and then you're only giving the answer. You're not showing any explanation. Surely you're thinking this. Oh, let me go look at my list of numbers here and find out what the limit as x goes to 2 from the left of f of x is. You're thinking to do that. So you need to be writing that you're doing that. And then if I'm asked, okay, find limit as x goes to 2 from the right of f of x over g of x, right? This is the statement of the problem, like that. Okay, well, I can look at this and go, oh, well, it's going to be -3 over -5, but I should write how I'm arriving at that. The limit, let's clean that up a little bit. The limit as x goes to 2 from the right of f of x over the limit as x goes to 2 from the right of g of x. That's going to be -3 over -5, which is 3/5, right? Then, much like up here, where we got agreement, now I can say, these agree. So then I can say that the limit as x goes to 2 of f of x over g of x equals 3/5 because the two one-side limits agree. What some people will do is they will do this instead. When asked to find the two-side limit, they'll look at the table of numbers and go, well, this limit doesn't exist because the two one-side limits are different, which is true. The limit as x goes to 2 of f of x does not exist, true. And they'll look at this, oh, well, the limit as x goes to 2 of g of x doesn't exist either, which is also true. But that's not what the question asks for. The question asks for the limit of the ratio. And we checked the left limit and the right limit, and they're the same. So that's the relevant comparison. The limit of the ratio, not the limit of the top and the limit of the bottom separately. It's instead the ratio. What is the limit of the ratio from the left and from the right, and does that exist? Anyway, those are some common errors and how to do them correctly. There's probably other things, but these are just a few of them. So if you have any questions, please email your instructor about that or talk to your tutor about that. So those are those examples.